Hello everyone, welcome back in this video. So in this video we are discussing about the torque requirement to overcome the friction in bearing. Okay, so it is very easy. So as you know, there is a formula for the linear velocity profile. So first we need to write this. Okay, so linear velocity profile. For this we have duy dy, so I can write it like uyt. Okay, so after that here you know that u is equal to tangential velocity of the shaft. Okay, this is shaft. Okay, and this is the length of the bearing, this is the natural radius. Okay, it is given, it is the rotational speed rpm. Okay, and it is radius of the shaft, and it is the viscous 2.5 of the lubricant which is filled here. Okay, so here u is the tangential velocity of the shaft and t is the thickness of oil film. Okay, so after that here it is the linear velocity profile. After that after this shear stress, okay, which is tau is equal to mu du y dy, so I can write it like mu uy t. Okay, from like this, which is written by me in the outline. So after this viscous force on the bearing, it is equal to shear stress into area. Okay, so shear stress is it is, so I can write mu uyt and area is 2 pi rl. Okay, it is like 2 pi r, it is like cylindrical, so l is the length. Okay, and for the frictional torque, it is equal to viscous force into radius. Okay, so what is viscous force? It is, so mu u y t into 2 pi rl into r. Okay, so after this here you write your given data now. So what is given data? First mu is equal to 2.5 poise, it is equal to 0.25 Newton second per meter square. Okay, you can see here it is given. Okay, so after that r is given, r is equal to 8 centimeter, so I need to write in meter. 0.08 meter, and L 30 centimeter, so it is also 0.3 meter. So from here I can find U. So U is equal to 2 pi Rn by 60. Okay, so you know what is U. Okay, I also write here. Use the tangential velocity of the surface. Tangential velocity of the shaft. Okay, and n is rotational speed, like in rpm. Okay, so now you can write 2 pi. What is r? R is 0.08, and what is rpm? Rpm is given is 200 divided by 60. So you can also write here n is equal to 200 rpm. Okay, so after that, after calculate all these value, I find 1.675 meter per second. Okay, it is the tangential velocity of the shaft. Now T is the thickness of the oil film, so it is 8.025 minus 8 is equal to 0.025 centimeter. Okay, so it is in centimeter. If I can write it in a meter, so it is 0.00025 meter. Now friction torque. Okay, for friction torque I have formula. T is equal to mu u by t. Okay, and 2 pi rl into r. Okay, so what is mu? Mu is 0.25. Okay, from here, and we also find u is 1.675. what is t? T is 0.00025, and 2 into pi. What is r? R is 0.08, and L is 0.3, and again R 0.08. Okay, so after calculating all of this, I get the value is 0.19 Newton meter. Okay, so it is frictional torque. And now the rotational speed of this shaft, which is omega. Rotational speed of the shaft, which is omega, which is equal to 2 pi n by 60. Okay, so for this 2 pi n is 200 is given, okay, divided by 60. So I get omega is equal to 20.93 radian per second. Okay, so after all of this, now last thing I need to require to get, which is power utilized. Okay, power utilized in overcoming the fractional torque. Okay, so P is equal to T tau. Okay, I have P omega or T omega. Okay, I have T, I have also omega. So now put the value of both of these here. I get 20.19 into 20.93, so it is equal to 422.5 Newton meter per second. Okay, P, or I can write it to 422.5 watt. So I hope you are clear till here. So thank you and have a nice day.